Okay, let's check out the last 5 problems on the 7th grade MCA packet, 36 through 40. Number 36 does refer back to the stem and leaf plot that we talked about earlier. And we're going to focus on the mean here because it says if a new student came into the class who is 48 inches tall, what would happen to the mean of this data set? Well, you are adding another person into the class, which will affect your mean, obviously. And you're adding in somebody who's shorter than the actual mean, which was 56. Okay, so the average was 56. If you bring in somebody that's shorter than that average, it's going to decrease your mean. So we're looking for A there. And you could actually go ahead and calculate that if you wanted to, but that would take you a little bit longer. Not much, especially if you have a calculator, but there you go. All right, number 37 uses this chart here. So this is company sizes by the number of employees. And it looks like we've got the number of companies and then on the vertical axis, and then the number of employees on the horizontal axis. All right, so let's see what this is asking us. It says, what information can be determined from the histogram above? A says the number of companies that have less than 20 employees. Now they do have a 0 to 20 section in here. However, it's saying strictly less than 20 employees. Some of those companies might have exactly 20 people. So we don't know how many are less than 20. So I can't say that, though it's tempting to say that one. B says the number of employees in each company. No, this doesn't tell us the number of employees in each company. All we have are ranges and how many companies fit into those ranges of employees. So it's not B. So we're down to C and D. Now let's just look at these. The number of companies that have from 51 and 60 employees. Well, 51 to 60 would fit in here, but I don't know which ones are between 51 and 60, so it's not that one. So let's hope that D makes sense here. The number of companies that have from 81 and 100 employees. Yes, we can figure that out. There is a section there, and that is 2 companies that have from 81 and 100 employees. So D is the correct answer for 37. Alrighty. Moving on to 38. Alright, use this figure for 38. What is the probability that a dart thrown at the figure above will land in the shaded portion? And we are able to round to the nearest percent. Okay, this is an area question. We're going to compare some areas. So the shaded portion, obviously we're not expecting a very large percentage here. And if you're observant, it's going to be less than half because there is way more unshaded space going on here. So I'm going to unofficially eliminate those two. If by some chance I am way off, which isn't the case, we'll find out. So you can kind of just visually think about it and say, okay, well, it's probably going to be A or B. So first of all, we want to figure out the area of the square. So this is a 5 by 5 square. So I would say for area-wise, that's 25. So the square is 25 square centimeters. All right? And then we want to figure out the area of the circle, which is pi times radius to the second. All right, so my radius, since this is my full distance across the circle, my radius is going to be 2.5, half of the diameter. So we'll go 3.14 times 2.5 to the second power. So we'll go 2.5 to the second power first, and then times that by 3.14. And when we do that, we get 6.25 when we square 2.5 times 3.14, and we get 19.625 square centimeters. Okay? And what we're going to want to do is we're going to want to actually figure out the area of that shaded portion, because that's what we're interested in. Well, the area of the shaded portion should be taking the square area and subtracting out the circle area. So if I take 25 minus 19.625, I will have that shaded portion area. So I'm going to take 25 minus that, and I get 5.375. how much of that area makes up the total square area. So I'm going to take 5.375 and divide it by 25 and see what we get here. So 5.375 divided by 25 is 0.215, and as a percent is 21.5%, but we get to round to the nearest percent. So about 22% chance that we have a dart that would land in that shaded portion. A lot of steps for that particular problem. Alright, 39. When flipping 3 coins, what is the probability of getting 3 tails? Well, first we need to look at all of our possibilities. Lots of different ways you can do this. 3 tails would be tails, tails, tails. Remember, there's also the possibility of heads, heads, heads. There's tails, heads, heads, and then I like to do all the opposites. Heads, tails, tails. There's also tails, heads, tails. And what's the one we're missing here? Let's see. Heads, heads, tails, and tails, heads, heads. Alright, so these are all the possibilities here. And you can come up with these in a few different ways. But there are 8 possibilities, and there's only one of these that gives you, so this is 1 out of 8, that gives you 3 tails. So 1/8 is what we're looking for there. Okay. Sometimes people use the, what's the word I'm looking for? The tree diagram to figure out all the possibilities. Alright, and lastly, number 40. We're looking at a spinner here. 8 equal sections. So it says Matt spins the spinner above 400 times and it lands on 6 43 times. How many times out of the 400 spins would you predict the spinner to land on 6? Well, since there's only 1 6 and it takes up about 1/8 of the space, I would predict 1/8 of 400 times. So 1/8 times 400, which is the same thing as 1/8 times 400 over 1, which is the same as 400 over 8. Well, how many 8s go into 400? Well, I know that 8 goes into 45 times, so 8 must go into 400 50 times. So I would expect about 50 times. There we go. So a little under when he did that, but pretty close anyway. So anyway, there's the end of the packet, and let me know if you have any questions.